Hi again. In the previous video I demonstrated how to join 3 STL files and turn those into one OBJ file. Now if you recall, in this OBJ file we had a scan flag, we had the implant or the analog, and we had something called a negative. Now the negative is the mesh geometry of the actual hole. Now you might recall that I mentioned that we have to turn this geometry of the hole into an actual object. So this object will then be placed into a finished model. Some other CAD programs work this slightly different. So I will show you how this works, and in so doing we will be able to get these analogs compatible with Blenderfordental. On the left hand side I've already started my work here. All of my folders, each folder carries the name of the actual part name. So I've converted all of these into OBJ, and in so doing I have radically downscaled the whole library. Within each one of those there are 3 STLs. So we'll continue with the 5mm NE in Blender, File, Import OBJ. So we're going to be looking for that here. This is the one. Make sure it matches, and then import. So the component standing upright, remember the Z-axis is facing upwards. So in the outliner window you'll be able to see that I have put suffix names onto each one of these files, and that is in the second category as well. So I'm going to be hiding all of those except for the analog sleeve, which is a negative. We've chosen to call the analog sleeve, well, because it's kind of a sleeve into which the analog fits into. If we have a look at this part, we can see that the bottom end caters for a screw, and this screw will tighten the analog from underneath the dental model. So already they have incorporated a ledge on the edge of this part. Now with these components I like to keep a wall thickness of 0.7 millimeters. That is to make sure it will print out, and in case you want to use the Gum Designer module where you might choose to have a removable soft surrounding, like a gum kind of effect around the implant that's removable. If we have a wall thickness of 0.7, that will print and that will jot out of the model, and your gum component will just slide over that. If we measure the this little ledge that they've provided here, we will see that in edit mode, tab into edit mode, and I'll be able just to take a measuring ruler here, and from the one side to the other we'll get to maybe 0.15. I'm going to be adding, say, 5.5 onto that, and then we'll have our wall thickness of 0.7. You can see that the top part of the component or the part is aligned with the bottom base plate here. This is kind of a plateau, and they sort of match together. So if I'm going to extrude this edge loop outwards by 0.55, and we do likewise with the lower one, we'll be able to get the top as a 0.7 wall thickness, which is what we want. Alright, so the other thing is you've got to use the tilde key here, because we have to view, you know, the part from exactly the front or the top or whichever. What we need to do is select the edge loop here. So my cross mouse here will just place it between the two vertices. And the other thing is you've got to make sure you work in transparent mode here, so we can see what's happening with the grid later on. So I'm going to select edge select this one here. So you're going to press Alt and left click. So you can see the perimeter is outlined. Then by using the tilde key, we want to look at the part from the top. Now, if your grid isn't set to 0.1, you can do that here. So here, by default, it is set to 1 millimeter. So we want to work in greater detail. I've reset that to 0.1. So do the same. Each square would measure the 0.1. Again, select the edge loop because I have accidentally deselected it. Alt left click. That's good practice, so you get the the hang of it. Tilde key, view it from the top. Alright, we're going to zoom in. Now it is important to take note of the following keystrokes. So we want to extrude this edge loop outwards and we want to size it outwards. So we're going to be pressing E followed by the letter S for size. E, extrude, S. Now we're going to count our 5.5. 1, 2, 3, 4, 5.5. Okay, set it down here, left click. Okay, so we've extruded that out. Now we have a wall thickness of approximately 0.7. We're going to view the part from the front, zoom out a little. We want to extrude our edge loop that's highlighted downwards into the Z direction. So press E and Z. Pull it all the way down. Okay, and left click. We're going to zoom in again. So what we want to do here is, instead we want to keep the plateau, but we want to create a little thin small ledge. So we can remember this component will be designed to be extruded through the dental model, both on the upper side of the dental model and the lower side. If you've got IPD implants, they have a screw entering laterally across to fasten the analog, so we want to make sure these will create perfect cutting tools for us. So I'm going to deselect this edge loop, so I'm going to press left click on the 3D space. I'm going to select the inner one here, Alt left click, and now we have to view it again from the front. Make sure you got it viewing exactly from the Y plane inward, so away from you. So we can zoom in here. I'm going to extrude that down by 0.1 millimeter. So E and Z, pull it down to this block here on the grid. Paste it down, left click. Okay, so we're going to reselect the outer edge loop, Alt and left click. We're going to view it again from the front, and we're going to match these two together. So we're going to push, this time not E, because we don't want to extrude a new edge loop, we just want to move it. So we're going to use G and in the Z direction, and just line it up with that line there. So from here we're going to double select. So the outer edge loop is selected, Shift, Alt and left click. So we've got both of these edge loops selected. I'm going to go up into Edge and choose Bridge Edge Loops. Okay, that joins the two. So you can sort of see what we're doing here. Next thing, keep those vertices selected. This is very important. Tilde key, front. Okay, now we don't know which one of these edge loop lies higher up on the Z axis than the other, which means that our cutting tool will not be able to select the correct surface. So in order to make this a surface on the horizontal, we have to match these two edge loops. So to do that, while they are selected, press S, then the letter Z. We're scaling in the Z direction to 0, and then push enter. So we've, just to recap, press S, press Z, press 0, and then press enter. So this has now averaged out the distance between those two edge loops, and it's set them both exactly the same on the horizontal plane, which means it should work. Okay, so from here we can just tab out of edit mode, we can get out of transparent mode, and we can have a look at our component now. So we have the screw access hole from underneath. We haven't tampered with the plateau. Please don't tamper with any parts of the mesh geometry of the hole. So all we've done is created a wall thickness to it by selecting the outer edge loops of each one, the top and the bottom. And this is what it looks like from the top. So if I go into the model designer now, press the N key, and we were to press face orientation, all of the vertices, the normals are in the correct order. Initially when we started, the red would be on the outside, which is okay for other CAD software where they're going to just connect the mesh geometry onto the scan and then make a model. So in our situation, we have made a model which will be inserted into the finished dental model. If you find that your expansion of your print resin is still tight, the component is still very tight to fit in, fortunately in the menu we have a scale button that you can use. We have scale buttons. So this would scale the mesh geometry of the whole, at least the whole object, out in a X and Y plane. Okay, so what we can do here is just expand the outliner window, and we're going to unhide our other components. If you have a look at the ScanBody, I'm going to just go into edit mode. This ScanBody has got many vertices, which is correct. I've come across other ScanBodies where, for example, the anti-rotation surface is just made up of one single face. Now this is incorrect because the ICP alignment tool, which matches the component ScanBody to the intraoral ScanBody, will seek out vertices and match vertices of this part onto vertices of the ScanBody in the intraoral scan. So if you have very little vertices or no vertices and just a face, the ICP will not make an accurate match. So in the instance, if you had too little vertices, you would you'd go into your edit mode there, you would select all of those, then you go into here, edge, and then you'd subdivide. I'm not going to press that because we've got sufficient vertices there. Tab out of there. So let us test our little gadget here. Before we do that, I'm going to just save this. So select all of the parts, go File, Export, OBJ, ensure that only this checkbox is ticked and that none of these are ticked except for the bottom one. Okay, so we're going to match that to, we're going to override it. It is red down here in the bottom here because Blender is telling us we're going to override something. Make sure the component names are correct so that they're correctly matching in your Explorer, in Blender, and in the Blender window. And then you're going to just push export. Okay, wait for that, and then it's going to update in my here in the Finder window. Just wait for it. Here we go. Okay, to test the device to see if it works, we're going to go into the component module. In the component module, go into the analog section. We're going to select the ScanBody. We're going to go into transparent mode, actually select it now. Using the B key, select all the other parts that are associated with the ScanBody, link it. Now you see the ScanBody being yellow. Of course we can push G and we can move it around. The the ScanBody is a parent, the others are the children. Where the parent goes, the children will follow in Blender terminology. Alright, so we're going to select the actual, now while we don't have a model here, we don't need to select a model and so on. Select model, we don't need to do this now for testing sake. We're going to just select the analog sleeve because it is called analog sleeve. The coding should pick it up. We're going to push select here. Select. Then we're going to select the top. The top vertices should be selected, so we can pull it up like that. Okay. And then we can click on that, takes us back out of edit mode. Click on bottom and then pull it out. So you should see the surface like that, and you should see the top surface like this. Okay, so we don't have side, we don't need to use that. Okay, so I'm going to just test it for safety measures. We want to just go here, select it, and then we're going to use the arrows this time, using it up, and then we're going to select the bottom, and then we're going to go down. Now this is the cutting tool which will cut through the model. So it's all fully functional, and then from here on we'll be making our way onto the abutment library. So the analog library is fully compatible this way. Thank you for watching the video.